Countdown.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Bismillahirrahmanirrahim. Wa bihi nasta'in la haula wala quwwata illa billahil aliyyil azim. Apa khabar pelajar-pelajar sekalian? Semoga semuanya berada dalam keadaan sihat wal afiat hendaknya. Diucapkan selamat datang ke kelas Kimia Perayu STPM Matrikulasi. Alhamdulillah, bersiaran lagi kita dalam kelas tuition online percuma yang dibawakan oleh Akademi YouTuber Malaysia dengan kerjasama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Sebelum kita mulakan kelas pada tengah hari ini, mulailah kiranya kita mulakan dengan bacaan Ummul Kitab, Al-Fatihah. Okay, sebelum kita mulakan kelas kita, ingin saya ingatkan kepada semua pelajar dan para penonton yang dikasihi sekalian, apabila menghantar komen, hendaklah menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tatapan umum. Sila fokus pada isi pelajaran yang akan disampaikan dan hanya menggunakan ruangan chat untuk mengutarakan soalan dan kemusykilan. Serta jika diberikan soalan, sila jawab pertanyaan dengan pantas. Juga diingatkan, link sijil penyertaan akan diberikan di penghujung kelas di akhir kelas ini. Sila ambil perhatian, link tersebut akan tamat tempohnya setengah jam selepas sesi berakhir. Sijil hanya dapat diakses melalui email e-didik sahaja. Kepada yang belum mempunyai email e-didik, silalah berdaftar dengan merujuk Telegram e-didik junior. Okey, para pelajar sekalian, tanpa melengah masa, kita akan mulakan kelas kita. Okey. Tunggu sebentar, saya tengah set up. Alright. Stop show. Okay. Okay, this is my poster. And here is my profile. My name is Shahnon bin Awi from College Matrikulasi Pulau Pinang. My teaching experience about 20 years. I'm start teaching chemistry matriculation since year 2000. And this is my channel, Shahnon channel. Alright, and this is our teammates, Perayu teammates, mathematics. We have Teacher Im. Teacher Im is leader for mathematics Perayu. And we have Teacher Aileen and also Cikgu Zana. This is our teammates of chemistry, led by me. And we have Cikgu Vivi Lau and Cikgu Mawar from Tingkatan 6. And Teacher Tang, also from matriculation. And teammates from biology, led by Teacher Faizah and we have Cikgu Fatia and Cikgu Naini. And the last one is accounting, led by Madam Fizi. And also we have Cikgu Yati. All right, and this is our portal Academy YouTuber Malaysia. Okay, www.academyyoutuber.com. You can surf here with our motto, bermula percuma, selamanya percuma. Alright. Okay, we go to our our lesson today, revision. Our revision today is chemical bonding. Chemical bonding is chapter 4 in matriculation syllabus, SK015. Okay, this is 4.1. Okay, chemical bonding. We have 4.1. Our syllabus is Lewis structure. Okay, we have to know how to draw the Lewis structure, draw the Lewis dot symbol, and then of course it has rules. We call it Octet Rule and exception for Octet Rule. For example, we have odd electron molecule, expanded octet, and also incomplete octet. Okay, the covalent character of beryllium, boron, and aluminium. Okay, and then formation of bond. Okay, formation of bond. We have ionic bond, covalent bond, dative bond, single bond, double bond, and triple bonds in formation of bond in Lewis dot symbol. Okay, and then the structure, drawing the Lewis structure, and then a formal charge. Okay, formal charge, the formula is number of valence electron minus number of lone pair minus number of bonds involved. And the use of formal charge is actually to determine the most plausible Lewis structure. And then we also have a resonance. You have to know how to write the resonance of molecule. And 4.2, we have a molecular shape. Molecular shape. We will use valence shell electron pair repulsion theory, or we just call it VESPER. Okay, basic molecular shape. Okay, the basic. We have 6 basics molecular shape. Linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. Is it 6? 6. Compare the repulsive forces. The lone pair versus lone pair is the strongest repulsion, and then lone pair and bonding pair. And the weakest of the repulsive force is bonding pair and bonding pair. And then we want to know the bond polarity of the molecule. All of these we can find it in valence shell electron pair repulsion theory. Okay, and 4.3 is hybridization, formation of 6 hybrid orbital. Okay, we have sp, sp2, sp3, sp3d, and sp3d2. Okay, we have to know how to draw the hybrid orbital of molecule. Okay, and the formation of sigma in pi bond. Save ke tak save lah ini? Save. Okay, yang ni save, boleh ulang tengok. Syakir Rashidi. Okay, and then 4.4 intermolecular forces. We have dipole-dipole interaction, London forces. Actually, dipole-dipole and London forces in one category. We call it van der Waals forces, and hydrogen bonding. Okay, effect on boiling point, solubility, and density. And the last one is 4.5 is metallic bond. We will use electron C model and then compare the boiling point between metallic element, metallic. All right, now we go to the we look at the resonance structure. Resonance structure in chemical bonding. For example, we take carbonate ion as an example. This is the resonance structure of carbonate. C double bond O, single bond O, and single bond O. In case of resonance structure, we have to write in this case for carbonate ion, we have to write 3 of them together. Okay, these 3 of structure represent the carbon ion. If we just write only one, that's not represent the carbonate ion. Okay, the different only on the double bond. As we can see here, the double bond here, C double bond O below here, and here the double bond in our left hand side, and this one C double bond O on our right hand side. Okay, we just change the position of double bond, then that is the resin structure. And here is the 3D structure of ice. This is also very, very important because this is the phenomenon for water. Because why? Ice can float in floats, okay? Because the water molecule in ice are bonded tetrahedrally by hydrogen bonding, okay? The tetrahedral arrangement leave a relatively large space between them and give rise to an open structure. As we can see here, we have a open structure here. Because of this, the has a bigger volume. The ice has bigger volume, hence smaller density than water. That's why ice can float, okay, in above water. All right. This is just simplified from this chapter, chemical bonding. Now we just go to the question. Okay. Okay. This is question number 1. Okay. Iodine can form compound with more than one oxidation state, like in ICl3 and ICl4 minus molecule. A. Draw the shape of ICl3 and ICl4 minus ion. B. State the bond angles between ICl3 and ICl4. All right. Number 1 is when we want to draw the shape of ICl3, we have to draw the shape. We have to know the shape. We have to use the Vesper model. Okay, we have to use the Vesper model because only Vesper model can predict the shape of molecule. First of all, before we predict using Vesper model, of course we have to write the Lewis structure. Okay, I think I will show you how to draw the Lewis structure. All right, let me see this one. Okay, try to zoom. Okay, something like this. Set up. Okay, how to draw the Lewis structure. All right, this one. First of all, we have to know the valence electron of iodine and chlorine. Okay, iodine, the valence electron is 7. We have to know because iodine, chlorine, group 17. So it has 7 valence electron. Chlorine also 7 times 3, 21. The total is 28. We will use this 28 electron. We have to use this to show the bond between ICl3. So I as a central atom and Cl as a terminal. The Cl here, chlorine, we have to make it octet. So we just put another 6 electron because the bonding pair is 2 electron. So we have just put another 3 lone pair. Okay, 3 lone pair. Now it's become octet already. Okay, if we count 8 electron here times 3 is 20, 24. The total electron is 28. We still remaining 4 electron. The 4 electron, we put it here. So this is the Lewis structure of ICl3. Okay, very easy. For ICl4, okay, same thing. I is 7, Cl is 7 times 4, 28. And we have a negative charge, plus 1. Total is 29, 36. 36. So 36 I Cl 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 minus, okay, for the terminal we make it octet. Okay, 8 all chlorine here has 8 electron. 8 times 4, 8 times 4, 32. Here is 36. Another 4. So 2 here, and 2 here. Okay, this is Lewis structure of ICL4 minus, and this is ICL3. Okay, let's go back to this one. So just cut this one. Set up. All right. Okay, go back to this one. So this is the Lewis structure of ICL3. Okay. So from here, we know this is a AX3E2. What is AX3E2? A is a central atom. X is a terminal atom. We have 3 terminal atom here, Cl, Cl, Cl. So X3. E is a lone pair. We have 2 lone pair here. AX3E2. From here, we know that it has 3 bonding pair. 1, 2, 3. 3 bonding pair. 2 lone pair. And the electron domain is 5. This is, we call it electron pair or electron domain. Okay. For 5 electron domain, if we refer to the Vesper model, this is trigonal bipyramidal. Okay, the basic shape is trigonal bipyramidal, but because this molecule has 2 lone pair, the geometry molecule is T-shape. Okay, this is derivative from trigonal bipyramidal. Okay, ICL3, the shape of ICL3 is T-shape. Okay, we already answered this question. Draw the shape. Okay, no, draw. Now we want to draw. We want to draw the shape of ICL3. Okay, make sure that the shape is look like a T shape. So this is yes, we know this is T shape. Okay, ICL. And to draw the shape, no need for us to write the lone pair on the terminal atom. But for the center, yes, we have to put the lone pair. So this is the T shape. And we can also answer the bond angle. Bond angle for the T shape is less than 90. Okay, less than 90. Okay, if you have any question, you can. Okay, Cikgu nampak separuh. Saya tak nampak soalan kat tepi tu. Now, I think you can see the. Boleh nampak? Sekarang boleh nampak ke lah? Okay. Okay, boleh tulis dekat tu kalau dah nampak. Kalau still tak nampak, boleh tulis. Masih tengok kat sini. Yes. Dah boleh nampak. Okay. Alright. Hai, saya form 3. Boleh. Form 3 pun boleh. Ilmu lah. Okay, Syam Nurin. If we put lone pair on terminal atom, does it wrong? Not wrong. Okay. Muhammad Iqmal, okay? Okay, not wrong. Okay, alright. This is the question. Alright. Okay. Now we go to the ICL4 minus. Okay. Okay. Now we go to the ICL minus. This is a Lewis structure of ICL minus. I've write it before. Okay. From this we know this is AX4E2. Okay. A is terminal. A is terminal. A is a central atom. X terminal. We have 4 and E2. Okay, and then 4 bonding pairs, 2 lone pair, and 6 electron pair. 6 domain pair. 6 domain pair is octahedral. Okay, octahedral. The basic shape is octahedral, and geometry molecule is square planar. In case of octahedral, it only has two derivative. Number one, we call it square pyramidal. Number two is this one, square planar. Okay. So now we want to draw the shape. Okay, make it like this. Okay, because we can see here this is a square. Okay, square, and then lone pair up and down, and the bond angle is 90. Okay, the bond angle is 90. All right. We go to the second question. Second question. Given the Lewis structure of three resonance structure of thiocyanate ion, acid minus, we have structure 1, S double bond C double bond N. Okay, number 2 is this one. This is resonance structure of Sn minus. Okay, we just change the single bond here, double bond here become single bond, but the double bond to the C and N. And then the third one is triple bond with S and carbon, sulfur and carbon, and single bond with N. Okay, calculate the formal charge of each atom in each resonance structure, and then give the most plausible structure. Because the formal charge, we use it to find the most plausible structure. This one is actually different from carbonate. Okay, before this, I show you the carbonate ion. The carbonate, because all the three terminal atom is the same one, oxygen. So we have take the three of the structures together, because all of terminal of carbonate ion is oxygen, but this one terminal atom for this thiocyanate is sulfur and nitrogen, different element. That's why we have to choose the best one. We call it plausible. All right, don't make it confused. Okay, remember the formula of formal charge. Valence electron of sulfur, we have to know the valence electron of sulfur. Okay, the valence electron of sulfur is 6. How do we know? I think the best way is you have to memorize it. Okay, sulfur in period 3, carbon in carbon and nitrogen in period 2. If you refer to my videos, how to remember the periodic table. Okay, the period 2, very easy. Liber-Birkenovna. Okay, Liber-Birkenovna, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. For period 3 is 6 galsip celar, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, and so on. All right, so for sulfur is 6 minus 1 2 3 4. Look at the lone pair here, 1 2 3 4, and bonding pair is 2. 6 minus 2, 6 minus 2, 6 minus 4 minus 2 is 0. So the formal charge of sulfur is 0. Carbon, the valence electron is 4. 4 minus 4, we have 4 bonding pair here. 4 minus 4, 0. Very easy. So ada tip tak nak ingat semua molecular geometry? Okay, I'll give the tips after this. Okay, nitrogen is 5. Okay, 5 minus 1 2 3 4. We have a 4 dot here, 4, and bonding pair 2. 5 minus 6, negative 1. And remember that when we total up the formal charge here, it must be equal to the charge, the total charge here. Total charge here, negative 1. Okay, 0 0 0 plus 0 plus minus 1 is equal to minus 1. All right, for structure 2, S. 6 minus 1 2 3 4 5 6 1. 7 so minus 1. Carbon 4 minus 4, 0. Nitrogen 5 minus 1 2 3 4 5, 0. Okay, nitrogen also 0. This one, sulfur is 6 minus 1 2 3 4 5, positive 1. Carbon 4 minus 1 2 3 4, 0. Nitrogen is 5. Valence electron is 5 minus 1 2 3 4 5 6 7. 5 minus 7. 5 minus 7. Well, negative 2. Okay, total up still negative 1. Okay, don't worry. The total, when we total up, it must be negative 1. If not, then you calculate it wrongly. Okay. Okay, now we already calculate the formal charge, and then we want to know which one is the most plausible. Okay, this is the answer. Structure 1. Okay, why we choose structure 1? Okay, structure 1 is the most plausible structure because, okay, this is the reason. Number 1 is the lowest moment charge. If you look at the structure 1, it has 2 0 here. Same thing goes to the structure 2, 2 0. But we can remove structure 3 because only 1 0. Okay, the 2 0 here means the lowest moment charge. If we have all 30, that's the best thing. But this one, of course, cannot because we have a negative charge here. Okay, the lowest form of charge in this case is 20 and -1. So we have to choose whether structure 1 or structure 2. Though, so it's come with this syarat lah. Okay, nitrogen atom is more electronegative than sulfur atom and has negative charge. If you look at this structure 1, the nitrogen atom here got the negative charge, but for this one, sulfur got the negative charge. But if you look at the negativity, nitrogen is more electronegative than sulfur. The problem is, how do we know which one is more electronegative, which one is less electronegative? Okay, please remember periodic table. When we cross a period, the element becomes more electronegative. And if we down a group, the element become more electropositive. The nitrogen at period 3 and sulfur at, nitrogen at period 2, sulfur at period 3. Okay. And then, of course, nitrogen has more electronegative than sulfur. Okay, something like that. And then because of that, because of these two factors, we choose structure 1 is the most plausible structure compared to the structure 2 and structure 3. All right. Okay, any other question? Ada tip nak ingat semua molekul geometri. Okay, nak ingat semua geometri molekul, we have a linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. 5. 5. Only 5. And a linear for trigonal planar, it has one derivative. We call it a V shape. Okay. For tetrahedral, it has two derivative. Trigonal pyramidal, and V shape, also V shape. And for trigonal bipyramidal, it has three derivative. Okay, number 1 is seesaw, number 2 is T shape, number 3 is linear. Okay, for octahedral only 2, square pyramidal and square planar. Easy the tips. All right, we go to the third question, I think. Okay, for SF4, NH3, and CCl4 molecule, draw their shapes and state whether this molecule are polar or non-polar. Now we want to know whether the molecule is polar or not. And once again, it's come to the Lewis structure. We have to know how to write the Lewis structure. Okay, this is Lewis structure of sulfur. Okay, how do I write the Lewis structure? Same thing. Sulfur has 6 valence electron. Okay, sulfur is in period 3, 6 valence electron, and fluorine 7 valence electron, group 17. Okay, total up. Okay, something like that. Only one lone pair. Same thing. AX4, E, 4 bonding pair, 1 lone pair, 5 electron pair, and this is 5 electron pair means trigonal bipyramidal. Okay, trigonal bipyramidal. Trigonal bipyramidal. Derivative, one of the derivative of trigonal bipyramidal is seesaw. Okay, the shape is seesaw, and okay, the polar bond. How we want to determine whether the molecule is polar or non-polar? Okay, first of all, we have to draw the seesaw molecule of SS4, and then we have to also draw the dipole moment of sulfur. We know that sulfur is more electronegative than sulfur, so the arrow must be to the sulfur. Okay, to the sulfur here, something like this, and something like this. That means the bond is polar. Okay, the bond is polar because we have the difference in electronegativity between sulfur and chlorine, sulfur and fluorine. So the polar is bond. But what happened to the molecule? Yes, the molecule also polar because the dipole moment cannot cancel each other. So the mu the mu is dipole moment not equal to 0 because cannot cancel each other. So the molecule also polar, right? Okay, I think we have to take a break. First, we will come again after this commercial break. Where is the break? Okay.
Berikutan pengumuman penutupan sekolah sehingga akhir persekolahan, pengajaran dan pembelajaran secara home-based learning tetap diteruskan. Oleh itu, kami di Akademi YouTuber menyediakan tuition online percuma pertama di Malaysia, dari prasekolah hinggalah ke sekolah menengah, dengan kerjasama E-Didik Malaysia dan Kelab Guru Malaysia. Kenapa bayar jika anda boleh dapat percuma? Bermula percuma, selamanya akan percuma. Manfaatkan peluang yang ada. Jangan tunggu lagi, startilah sekarang. Untuk maklumat lanjut, layari www.academyyoutuber.com.
Dibawakan kepada anda oleh Akademi YouTuber.
Okay, welcome back. Okay, this is we want to draw the shape and whether the molecule is polar or non-polar. Okay, the second one is ammonia and H3. Okay, this is the Lewis structure of ammonia and H3. It has 3 bonding pair and 1 lone pair. Okay, X3E. Okay, the electron domain is 4, and the shape is trigonal pyramidal. Okay, shape is trigonal pyramidal for ammonia. The bond is polar. Okay, mu is not equal to 0, and the molecule also polar. Okay, we will write like this: N and H. Okay, this is the arrow represent the dipole moment and cannot cancel each other. And then the polar also molecule. All right, we have a question here. Adakah kalau ada lone pair mesti dikira polar molecule atau tak semestinya? Okay. In case of double bond, lone pair, only 2 molecule with lone pair, and yet it's not, and yet it's non-polar. Okay. Number one is linear in a derivative of trigonal bipyramidal. Linear from trigonal bipyramidal, because the shape is actually is symmetry. Okay, symmetry. The one is it has a lone pair, but the dipole moment can cancel each other, so the molecule is non-polar. And number 2 is square planar. Square planar derivative from octahedral. Okay, because the lone pair can cancel each other up and down, and also the shape is also symmetry. Okay, the polar molecule because actually the molecule is asymmetry or not symmetry. Okay. Macam mana nak tahu polar or non-polar? Okay. First we have to know the difference in electronegativity of atom. For example, in this one, sulfur and chlorine, sulfur and fluorine. We know that fluorine is more electronegative than sulfur. So the bond is polar. For example, HCl, H and Cl. Cl is more electronegative than hydrogen, so the molecule is polar. Oxygen, O2, no different in polarity. That's why oxygen is non-polar. O2 non-polar, Cl2 non-polar, F2 non-polar because no different in electronegativity. Okay, the bond is not polar. Of course, the molecule also not polar. But we can have the bond is polar, but the molecule is non-polar. Okay, look at this CCl4. For example, we have CCl4. This is the Lewis structure of CCl4. AX4, 4 bonding pair and 0 lone pair, no lone pair. So 4 electron pair. Usually, if the molecule is non-polar, the molecule no lone pair. Okay, no lone pair, and the terminal is the same. Guarantee the molecule is non-polar. Okay, like this, like this. We have the same terminal atom, all of chlorine, and it's take the basic shape of molecule tetrahedral. The bond is polar because we can see the differences in terms of electronegativity between carbon and chlorine. But the molecule become non-polar because the dipole moment can cancel each other. Okay, the dipole moment can cancel each other. The mu equal to 0. the molecule is non-polar. Tak nampak yang bawah. Let me see. Oh, tak nampak yang bawah. Okay. Tak nampak yang bawah. This one is how to adjust. Maybe I can. Okay, let me get this. I stop this one. The banner. Okay, I stop the banner. Where is the banner? I stop the banner. Oh, so comment also. Comment. Alright. Boleh nampak? Alright. Okay, comment. Stop. Okay. Okay. Good. Screen bawah sekarang dah boleh nampak dah. Okay. Now you can see the screen. Okay, the shape is tetrahedral. Okay, shape is tetrahedral. Bond is polar. Bond polar. Okay, because chlorine and carbon has different electronegativity, but the dipole moment cancel each other because it take the shape of basic shape. Remember that the basic shape are linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. That is basic shape. Usually, if we have the basic shape and all the terminal is the same, it will cancel each other. We don't have to look to the differences in electronegativity between center and terminal. We can predict the molecule must be non-polar. But if you change, for example, CCl3F, okay, we change one of the Cl here with fluorine, of course, this will become polar molecule because the molecule now is asymmetry. The molecule now is not symmetry. Okay, of course, the dipole moment cannot cancel each other. The resultant moment cannot cancel each other, and the molecule will be polar. Okay. All right. Sekarang dah boleh. Good. Okay, the question number 4. This one is all right. What is meant by hybridization? Sketch and label the diagram of orbital overlapping in ethene C2H4 and explain the hybridization of the carbon atom. First of all, this is meant by hybridization. The mixing of different type of atomic orbital. Different type of orbital must be different type of orbital. For example, s orbital and p orbital. To produce a set of equivalent hybrid orbital, the hybrid orbital must be equivalent in terms of energy level. Okay, and then we want to sketch and label diagram of ethene. First of all, even though this is a hybrid, the first step is we have to write the Lewis structure. This is Lewis structure of ethene. C, double bond C, H, and H. This is Lewis structure of ethene. All right. From this structure, okay, we know that this carbon has three. We call it sigma bond, 1, 2, 3, and for the second one is pi bond. Okay, pi bond, sigma, 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 pi. In this case, we have 1, 2, 3, 4, 5, 5 sigma bond and 1 pi bond. Okay, we have to analyze first before we write the overlapping of ethene. Okay, and then um, we have to write the carbon ground state. In ground state of carbon, of course, we have to write only the valence electron of carbon. Carbon has 6 electron and 1s2, 2s2, and 2p6, 2p6, 2p2, 2p2, 6 electron, and only write the valence electron. 2s, 2 electron here, and 2 electron on 2p orbital. If you look at this for carbon here, the carbon here has electron which is single, 1 here, 2 here, 3, 4. That means carbon must has single electron, but for ground state of carbon, the electron here is in pair, yeah, 2s in pair. So we have to excite this electron to the empty p orbital here, right? We call it excited state. Okay. How do we know? We refer to the Lewis structure. Okay, we refer to the Lewis structure. Uh, for this one, for this 2s orbital here, it's actually represent the lone pair. Okay, you will see other example that the molecule has lone pair. So in that case, we have to remain the 2s like this. Okay, this actually represent to the lone pair. Okay, but here we cannot see any lone pair, so we have to excite this electron to the 2p orbital here. So it's become here. And then hybrid. Okay, look at this Lewis structure. How do I know this is sp2? I just count the sigma bond. 1, 2, 3. For 3, sp2. If we have 2 sp, the hybrid orbital begin from sp. Sp is for linear, 2 sigma bond. sp2, 3 sigma bond. Okay, 1, 2, 3, 1, 2, 3. For carbon here also 3, 1, 2, 3. Okay, that's why I know this is sp2. And then I take this 2p here, combine with s orbital here, and it's become sp2, 1s, and 2p. That's why we have 3 orbital here. And this sp2 here represent to one box here, and one box here. That means sp2 we have 3 boxes here. And for unhybrid orbital here, 1 here. This is actually for pi bond here, pi for the second bond here. Okay, pi bond. And for hydrogen, it is in ground state. Okay, hydrogen only has one valence electron, one s, and it's in ground state. No excited state because hydrogen only has one s, no 2s. Okay. Okay, after this, we have to write the, but this one is, I think I have to draw one by one, okay, to show you. So I have to make it like this again. Where is it? Okay, first set up for this one. Okay, all right. Oh, until here. Just a minute. All right. Okay. Okay. We already know this is sp2 is also sp2. Okay, this carbon will use sp2 hybrid orbital to overlap. And for hydrogen, we'll use s orbital. Okay. Now, this is the shape of this carbon. Shape of sp2 is a trigonal planar. Yeah? This one sp2. We have to label sp2, 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 sp2. Okay. Okay. And here we have an electron here. We have 3 electron here. And look at here, the sp2 here overlap with s orbital of hydrogen. Orbital hydrogen is sphere. This is hydrogen. Hydrogen use s orbital overlap here to form sigma bond. Okay, we settle here, settle here, settle here. And here, let's say this is carbon number 1, this is carbon number 2. Carbon number 2 also use sp2 hybrid orbital overlap end to end. Okay, like this. This is sp2, 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 and form sigma bond. Okay, sigma bond. And don't forget hydrogen here. Hydrogen. We have orbital of hydrogen here. Use s orbital. This is sigma. We have sigma bond, 5 sigma bond here. 1, 2, 3, 4, 5. Settle. Now, for pi bond must be perpendicular to the sp2 hybrid orbital like this. 1 electron here. And for this carbon also, make sure that the electron here with different this one is the arrow is up, this one is down. This and this will overlap side to side to form pi bond. Okay, this is how we write the we draw the orbital overlapping of C2H4. Okay, we have to label. This is p orbital. Okay, this is p orbital or 2p orbital. Label. We have to label of all of them. 2p orbital. This is anhybrid orbital of carbon. This is hybrid orbital sp2, sp2, sp2. We have 3 sp2 hybrid orbital of carbon. And for adjacent of this carbon, also 3 sp2 hybrid orbital and 1 2p orbital overlap side to side. Okay. Alright, let's get this one. Let's get. Okay, I have to do this one again. Alright. Okay. So, ada double bond. Sebab nak. Okay. Kenapa tak boleh letak sp3? Memang tak boleh lah. Because we refer to the this Resin Structure. sp3 means sp3 it has 3 sp3 for tetrahedral, sp3 for tetrahedral, right? But this one is not tetrahedral. This is trigonal planar. Trigonal planar is sp2. Remember that sp is linear, sp2 is trigonal planar. Okay, if you refer to this one carbon, trigonal planar. sp3 is tetrahedral. sp3d trigonal bipyramidal. sp3d2 octahedral. Okay, so this is the final structure of overlapping of in ethene. Okay, as I draw before this. Okay, something like that. Now I want to explain. Okay, and explain the hybridization in the carbon atom. Okay, 2 sp2 hybridized orbital of carbon atom, 2 orbital, because this carbon has 3 sp2 hybridized. But 2 of them, 2 of sp2 hybridized overlap end to end with s orbital of hydrogen, 2h hydrogen. Okay, the same thing goes to here, 2. And then one sp2 hybridized orbital of carbon, this one orbital of sp2 hybridized carbon, overlap end to end with sp2 hybridized orbital of carbon, this one, to form 5 sigma bond. 1, 2, 3, 4, 5. Okay, form 5. And then one unhybridized p orbital of carbon atom, this one of unhybridized p orbital of carbon, overlap side to side, something like this, side to side, to form pi bond. So we have one pi bond. One pi bond is actually represented by this restructure, the second bond from C and C here. Ada double bond. Okay, macam mana nak tengok sigma bond? Okay, sigma bond, double bond. Okay, we have triple bond. Okay, triple bond. The first one is sigma bond. The rest of the two is sigma bond. The pi bond. Okay, that's why we have to know how to write the Lewis structure. Okay, if we write the Lewis structure, we know that okay, this structure has how many pi bond, how many sigma bond. Okay, that's why I just leave it here to we want to refer. Okay, this one we have one pi bond. This one is how many sigma bond and so on. Okay, Mustaqib Marsyidi, macam mana nak tengok sigma bond? Okay. Okay, we go to the question number 5. Question number 5. Determine which of the compounds, hydrogen bromide, HBr, or carbon tetrafluoride, CF4, has a higher boiling point. Explain. Again, the question like this, boiling point, but we have to actually write the Lewis structure. Okay, actually, if we write the Lewis structure, which is it? Okay, okay. The boiling point of HBr higher than CH4. How do I know? Because HBr is polar. How do I know that HBr is polar? Okay, because HBr, we only has one hydrogen atom and Br. Of course, the shape is linear. Okay, linear, only two. And Br, bromine, is more electronegative than hydrogen. So the polar is bond, and the molecule also, and the polar is bond. The bond is polar, and the molecule also polar. Okay, HBr is polar molecule. While for F4 is non-polar molecule. Usually, we know that polar molecule, the intermolecular force between polar molecule stronger than non-polar molecule. Okay, intermolecular forces in HBr. Okay, intermolecular forces in HBr is dipole-dipole interaction. Okay, polar molecule double-double interaction, which is stronger than weak London forces. For non-polar molecule, the intermolecular force is London forces. Okay, weak London forces. London forces is less stronger than double forces. Okay, double forces. That's why the stronger the stronger the intermolecular forces, the higher the boiling point. Okay, the boiling point. The indicator for boiling point is intermolecular forces. The stronger the intermolecular forces, the higher the boiling point. Okay. Okay, this is question number 5. And then any question? Okay, no question. We go to the question number 6. Arrange the following compound in order of increasing boiling point. Explain your answer. Now we want to arrange the compound in order of increasing boiling point. Okay, look at this. We have H2O, we have methanol and ethanol. Okay, CH3OH is methanol, ethanol. Okay, like this. Methanol is the lowest boiling point, methanol, followed by ethanol, and H2O, uh, the highest in boiling point. Okay, now we want to explain. Okay, all molecule can form hydrogen bond. Okay, H2O, 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 water, methanol, and ethanol can form hydrogen bond. Okay, between their molecule. Why H2O? Higher boiling point. Okay, this is the reason. H2O can form more hydrogen bonding. Maximum is 4 hydrogen bonding per molecule. H2O, we know that it can form maximum 4 hydrogen bonding. Lone pair, on oxygen atom, it has 2 lone pair that can form 2 hydrogen bond, and H, okay, hydrogen, H2O has 2H, also can form hydrogen bond. So maximum it can form 4 hydrogen bond per molecule. Whereas for methanol and ethanol, only 3 hydrogen bond maximum can form 3 hydrogen bond. 2 on lone pair on oxygen of alcohol here, and 1 from H. That's why hydrogen uh, can form the hydrogen bond in H2O is stronger than hydrogen bond in alcohol, okay, because it can form more hydrogen bond per molecule. And then why ethanol stronger hydrogen bond than methanol? Okay, this is because of molecular size. If you look at the molecular size of ethanol, bigger than CH3OH, we no need for us to calculate, because we know here we have 2 carbon here in only C, one C, and here is 1O, and 6H, and here is 4H. Okay, without calculation, we already know that molecular size of ethanol is bigger, okay, bigger than ethanol, therefore stronger van der Waals forces. Okay, that's why ethanol has stronger van der Waals forces. In terms of hydrogen bond, they both of them equal. Okay, in terms of hydrogen bonding for ethanol and methanol equal, but in terms of size, okay, because the size it's related to the van der Waals forces. The van der Waals forces of ethanol stronger than ethanol. All right. Okay, the last one is compare. Okay, we have 2 minutes. Okay. Compare the boiling point of bila yang kena kaitkan dengan molecular size. Okay, molecular size if the molecular force is the same, like this one, ethanol and methanol. This is ethanol and methanol. Same intermolecular force, which is hydrogen bonding. And hydrogen bonding in alcohol is H and O. Here also H and O. So same. So we have to find another factor. And for this one, the factor is molecular size. But for water, even though the size of water is smaller compared to alcohol, but we refer to the number of hydrogen bond. H2O can form more hydrogen bond. The more the number of hydrogen bond, the stronger the hydrogen bond. Okay, it has 4 hydrogen bond, even though the molecular size of H2O small. Okay, 18 gram per mole, only 18 gram per mole. This one is 46. Okay, 46. But because of number of stronger hydrogen bond. Okay. Okay, good. Okay. Now we go to the sodium, aluminum, and magnesium. Compare the boiling point. This is a metallic bond. Okay. Increasing boiling point is from sodium. Sodium is the smallest in boiling point. followed by magnesium and aluminium. Okay, why? The strength of metallic bond is proportional to the number of valence electron. As we know that the number of valence electron in sodium is 1. Okay, sodium in group 1, magnesium in group 2, aluminum in group 3. Okay, group 3. Group 3. Group 3. Okay, number of valence electron of aluminium is higher because the strength in metallic bond, one of the factor of strength in metallic bond is number of valence electron. Okay, the bigger the number of valence electron, the stronger the metallic bond. And the second one is the size. Okay, the smaller the size. And in this case, aluminum also has the smaller size compared to magnesium and sodium. Yes, because sodium, magnesium, aluminum in period 3 cross a period. Okay, cross a period, the size of element become smaller. Okay, become smaller. But we can use this number of valence electron to uh, to to show the boiling point. Okay. Okay. Any question? Size. Okay. I think we are running out of time. So this is my channel. Okay. www.youtube.com Shahnon channel. So please come to my channel. All right. Oh, before we before I forget that we have a link for open link, save link, copy link address. Okay, wait a minute. Okay, for those that has EDD, you can use this link and copy and wait. Okay, wait a minute. The password is kelas AYU EDD. Okay, kelas AYU EDD. Kelas AYU EDD. Okay, this one. This is the password. Kelas AYU EDD. Okay, you can use this one to get your sigil. Okay, I think that's all for today. See you again in next lesson. Okay, maybe not me, maybe me or my teams. Okay, that's all. Assalamualaikum warahmatullahi wabarakatuh. And salam sejahtera.